In this lesson, we'll learn how to easily deform a complex space frame structure. Using this technique, you can pretty much use it to deform anything you like, and I've seen people even create massive curved towers using this type of technique. So what I'm going to do first of all is just to view the objects that I'm going to be working on. I'm going to select the space frame layer, select the object within the scene, and then isolate that out. Now, if you remember when we created this, we basically mirror instanced this bottom layer. So I need to now undo that instancing so that any changes I make to the top will not affect the bottom structure. So I'm going down, I'm just removing that instanced function, and I'm going to now isolate out just the top layer. Before I isolate it completely, I'd like to include my two objects that I'm going to be working with, and basically I want to see the full depth of this form as well as the sphere. Now the idea here is that we want to deform the top space frame structure so that it feels as though this sphere is just nestled gently within it. So that can seem like quite a complex thing to do because we do already have quite a complex structure, and you may think, how am I going to go and deform all of this? Well, luckily the way we created our structure makes it very, very editable, and that's hence why I prefer using these type of techniques where everything is basically derived from a simple plane object instead of multiple instanced small objects around the entire scene. So now having this plane, you have quite a lot of options as to how you can go and manipulate it. You can add an editable poly modifier, and this will allow you to then take individual vertices of your choosing and you can go and move them around. You can either move them in this fashion, or you can go and add the soft selection option. So you could have a soft selection of perhaps 6 meters, and if I go and choose the central vertices in the middle of the sphere area, I can go and increase that soft selection until more or less the entire sphere area is taken up. I can then move that entire section down, and I can keep increasing my smoothing until I feel happy that this form looks correct. Now I'm going to move it just to about that level, and there we basically have our form. I just wanted to show you on the side that there are other methods you can use to create this. I'm going to keep with this soft selection method because it is quite clean in my case, but if you don't have such a dense mesh that allows you to do it, you can also choose to use the second method, and that one being the freeform deform modifier. So I'm going to go just off the screen. I'm going to actually go to this one down here, which is called freeform deform box. And the reason why this one is quite great is because it allows you to set the number of points for yourself. So I can set a height of 2 because I don't have much height to work with, and the length I can set to 10, and the width I can set to 20, for example. And this will give me quite a dense mesh, a little bit less dense than the actual mesh, and you could even go and reduce that at any point in time before you start deforming it too much, and you could perhaps have something like this. So once you then right click and go to your control points, you can pretty much have the same control, and you can see that you have this wave effect. But what I don't like particularly is that it creates a spline out of your form, and it basically will counter deform in the opposite direction, and that's something that using soft selection doesn't do. So it's good to know the two techniques because the freeform deform is very, very powerful, but there are some cases where it may not be applicable. So what happens right now with our object that we've gone and deformed is we can go and reapply all of the edits that we made before, and you can see that all of the triangles that have basically been created, they work perpendicularly to the face that they are being extruded out of. This is the reason why I really like it, is because if we added the deform on top of the lattice and the editable poly, we would not have this result. We would have something that looks much, much worse. So this is a much more real-world scenario of how the structure would be supported. Then once your lattice is on, you have quite a neat looking space frame that basically looks quite feasible. So one of the complexities with doing this is that now you have this bottom layer to work out. Now you'll see immediately once I just remove this lattice, you can see a little bit clearer, is that now you need to start deforming this bottom layer. But if you go and deform it using the same editable poly, if I just drag that across, you'll see that I get a undesired result. In other words, the poly IDs are not really the same, and we start to get something that doesn't really correspond. So if I wanted to take the editable poly underneath and move it down individually with soft selection, I would never get it to match up with the points that are underneath these pyramids. So we need to choose a completely different way of doing this. Now, the other thing I can't do is I can't just take this object again and move it down by 2 meters, is because this is actually extracted or deformed in a radial fashion, basically. So the only way that we're going to get this right is to basically use a shell modifier and then to work with that result. So let's go now into this object and create a copy. So Control V again, and I'm going to remove all of the top level editable poly geometry. So editable poly and lattice, which basically gave it that 3D shape, is now going to disappear, and I'm going to instead choose a shell. So that shell is going to be created with a 2 meter inner amount, and that will basically, very much in the same way that we had done the triangulation for the pyramid, will basically create a thick shell, and these panels will now all align so that the central point of the square will be where that point is. Now what we need to do is a little bit complex, because we can't just move it across by one module as we did when we were doing the very flat and plain space frame. If you hadn't watched the lesson on the space frames, you can go back in the course and just have a look at how we created that space frame so that all of this will make more sense. So what we need to do now is extract out this bottom surface. So let's go and add another editable poly on top of this. And we're going to choose the poly selection by angle, and we're going to select that entire bottom area. I'm going to Control I to delete the inverse. And now what we need to do is add a tessellate modifier, which will basically give us an extra level of edges that is going to be running through where each of these points are. So it's a little bit complex to see because the geometry is starting to become quite dense, but basically you can see that we now have a line of edges that is going to follow, and it's going to line up exactly with these points. So here we can start to see it a little bit better. In some cases it might be off by a few millimeters, but because we are working with a conceptual model, this is perfectly fine, because it basically, that 2 meter extracted face that we used to generate this triangle and the 2 meter extracted poly that was used to generate this bottom surface basically is going in the same direction. So now what we need to do is a little bit of a long-winded basically action to this mesh. We basically, before we add a lattice modifier, we need to remove this line of edges, and we need to also remove that line. So if I just click on loop, I need to right click and remove that. We basically need to do that function to all of the edges that we don't want. So I'm going to pause the video now and just remove those in the same way that I had removed these, and then we can have a look at the final result once we add that lattice modifier back. So now the Esch editing has been completed. It did take about 2-3 minutes to do, and it is probably one of the most long-winded processes of this whole modeling sequence, but it is one of those things that is required. So if you have a look now at the vertex level, you can see that there are some free non-connected vertices here at all these points, but they're not going to make any difference once we create our lattice. So all of those can stay in. Usually if I'm creating a small mesh, I would just go and select them, right click and remove them. But here I'm definitely not going to do that, because it would take far too much time just to create 30 selections in one direction and 15 in the other. So I'm going to now go to my main object. I'm going to turn on lattice and copy and instance that lattice across, and you can see now that you have a space frame object that has all of these points now lining up with that bottom space frame. So each of these points now very neatly lines up, and the only reason why there was a few millimeters of difference is because when we created the tessellate, there was a 25 tension, and you can see that's what actually created that offset that I was talking about. But once you remove the tension, it becomes a pure geometry that isn't distorted, so you're going to have a much more accurate result and a very good space frame look once you have that created. So you can see now that the two space frames, they almost come together and they meet in this point. If we look in our front view, you can see pretty much what we've created is that we have a space frame coming down and meeting, and this is pretty much the point where this main tower is going to come up, and people would most likely at this point have access ways to go into this entire space. And it would be quite an interesting look to get to this point. I think now in the next lesson we can look at creating more detail to this central element, which is the main arrival area. So here we actually see that arrival box on the river shore side, and that's what we're going to be walking through, go over the bridge, and then up into this massive, massive tower. So that is pretty much it for this lesson. Thanks for watching so far, and hopefully you have seen how quickly we have been able to distort and modify such a large complex form without really having to do any complex remodeling at all. So now we're going to jump into the central tower part in the next lesson. So we're going to look at how we can add some more flavor and detail to that part.